Okay, welcome back. I hope you can see this a little bit better. It looks better on my screen. The internet at my house has been updated. The last couple of videos I had to do recording and uploading them, and it took probably around 3 hours per video. So it was a little ridiculous, but I've got new internet at the house, so hopefully we can do live sessions like this one is, but nobody's here because I didn't tell you what's happening. So you'll be watching this later. But in the live sessions, which I'm trying to get the class to go to, we will end up having a chat over here on the other side of the video itself. If you join me for a live session, you can actually ask a question or say, hey, I don't understand that, slow down. So hopefully that's how our class will be run from here on out. But this is the review for Math 127, the Exam 2 review. I decided to do it today, Sunday, to post it so that we can, so you can go through and look at it and have some time to review it and ask questions between now and the exam. The exam, of course, for 127 is on Wednesday. So again, you'll be taking that on the JMOV website, the same website you've been doing your homework on. So it'll be there. You'll have 3 hours to do it. And then again, of course, all of your same stipulations for any test will apply, where you cannot use notes, things like that. So take those tests on your honor with no outside aid. But let's get started. The first question from the review that I had was number 5. That's what we're looking at. I hope you can see that. I don't know what the lighting in this room is horrific. I can't tell if that's better or not, but I can see it. Hopefully you can. So let's go with this. Number 5 tells us that we're given that sine of x is 5 over 13 and is in quadrant 1. We're also given that cosine of y, so a different angle, but the cosine of y is negative 2 root 5 over 5. And y is in quadrant 3. Okay, so I have those two things, and we're asked to calculate a bunch of different things. So we'll start here with the first, and I'll do a couple of these. I won't do all of them, but I'll do a couple so that we can get the idea. But the first thing they ask is what cosine of x plus y is. So you need to know that the cosine of x plus y is it's one of our identities. It's a sum identity, right? This is equal to, I'm not going to have enough room there. This is equal to the cosine of x times the cosine of y. Right, multiply, or sorry, minus the sine of x times the sine of y. Right. So we have that identity, and we're going to use that identity. But in order to use that identity, I don't know cosine of x. I know sine of x. And I don't know the sine of y. I do know the cosine of y, but I need to figure out the other two. And so I'm going to take a moment and figure out what those values are. And in fact, once I do that, I can use those values through the rest of the question, right? So x, though, gives me, since x is in quadrant 1, I have some angle in quadrant 1, right? Where x is my angle. And the sine of that x is 5 over 13. So that tells me that the y value is 5 and the hypotenuse is 13. And you can use a Pythagorean identity to figure out this bottom side here, but you should probably recognize this as a 5, 12, 13 triangle. So I have that, 5, 12, 13. Right? I also have this information about y. Y is in quadrant 3. So a quadrant 3 triangle is going to come down here to the bottom left. I know that the cosine is negative 2 root 5 over 5. So I need to draw this a little lower so I can label it. The cosine is negative 2 root 5. That means I've got negative 2 root 5 for my x value. And then 5 is my hypotenuse. Right? And then I just have to figure out what the y value of that triangle is. Right? So I'll do that down here. I have to solve a Pythagorean. X squared plus y squared equals r squared. So that means that I have to solve, let's just call this, y is a bad thing because this angle is y. So it doesn't matter what I call it. I'm just going to call it question mark because it doesn't matter. But I have to have question mark squared. My question mark turned into a 2. Maybe that's a bad idea too. I'm just going to call it a. For now, it doesn't matter. Call it whatever you want. But a squared now plus that negative 2 root 5 squared has to be equal to the radius 5 squared. And so that is to say that I have a squared plus, when I multiply all of this, there's negative 2 root 5 squared goes positive. The 2 gets squared, so that's a 4. The root 5 gets squared, so that's a 5. So this ends up being 20. 5 squared is 25. Subtract your 20 from both sides. And I've got a squared equals 5. And so a equals the square root of 5. And it's negative because, again, y is in quadrant 3. So if y is in quadrant 3, that tells me this is negative root 5. So I have negative square root of 5. I'm going to erase this blue, so if you need a minute to write that down, pause it. Because it's doing now. I'm going to try to use maybe my darker markers. That green, I can't tell if it's showing up very well. So I'll stick with this, but I've got cosine of x. The cosine of x comes from this triangle. The cosine is 12 over 13. Multiplied by the cosine of y. The cosine of y is negative 2 root 5 over 5. Minus the sine of x. The sine of x comes from my first triangle. That is a 5 over 13 times the sine of y, and the sine of y is negative root 5 over 5. So if I multiply these two together here, that gives me negative 24 root 5 over 65. Minus, but when I minus these two, 5 times the negative goes minus, so there's 2 minuses, so that's a plus. And that's just 5 root 5. Over, again, 65. And so then I can combine these because they have the same radical and they're over the same exponent. So negative 24 plus 5 is negative 19 root 5 over 65. And that, if I recall, is the answer on the solutions to this. So that's it. I'm going to leave these triangles up here because I'm going to use them for the rest of the numbers that I do in number 5. So I'll leave those there because once I've done them, I don't need to do them again. So let's take a look at B. So B says find the sine of x minus y. There's an identity here as well. Sine of x minus y is equal to the sine of x times the cosine of y, right? Minus the cosine of x times the sine of y. Right? But again, these all come from these triangles, so I have the sine of x, that is 5 over 13, times the cosine of y. The cosine of y is negative 2 root 5. I don't know what I'm writing there. Negative 2 root 5 over 5 minus the cosine of x, which is 12 over 13, multiplied by the sine of y, which is a negative root 5 over 5. And so I have on the left negative 2 root 5 over 13 times 5, 65. Minus minus goes plus again, so I have 12 root 5 over 65. I can combine these. Negative 10, positive 12, that's 2. Root 5 all over 65. And that's B. All right, let me do D. I'm going to skip to D. I think C is similar to those, so I'll let you figure that one out. D says cosine of 2x. That's an identity as well. It's the double angle identity. The cosine of 2x is equal to, there's 3 of them, right? But we can use cosine squared of x minus sine squared of x. Right? The cosine of x comes from here. That's 12 over 13. That gets squared. Minus the sine of x squared. The sine is negative root 5 over 5. That gets squared. Right? And so this becomes a 144 over 13 squared is 169. Minus the negative goes away here, but I end up with just a 5 over a, oh, my bad. I used sine of y. I used the wrong triangle. So let's back up for a second. This is not correct. The cosine of x came from here, 12 over 13. So I have 12 over 13. That gets squared. I'm still using x. I don't need anything to do with y. Sine squared of x is 5 over 13. So that is 5 over 13. And that gets squared. So I have 144 over 169 minus 25 over 169. And then, of course, 144 minus 25, that gives me 119. over 169. You'd want to see if you can simplify these. Most of the time you're not going to be able to. Sometimes you can. This one is not simplifiable because 169 is just 13 times 13, and 119 is not divisible by 13. So that's D using the and then I want to look at E as well on this one. So let's look at E. E says find sine of y over 2. Okay. So we have a half angle formula, and that half angle formula has a plus or a minus, and then the square root. And if it's a sine, there's a minus on the inside of the square root. So this becomes 1 minus, and then it's always a cosine of whatever this angle is before it gets halved. And then the whole thing is over 2. The question is, I think most people have is, do I use positive or negative, and how do I know, right? Well, if y is in quadrant 3, we can argue then down here in quadrant 3. But if you half those, right, half of 180 is 90. And half of 270 is 135. So I know that y over 2 is somewhere between 90 and 135. That's in quadrant 2, right? And if it's in quadrant 2, the sign is positive. So I know that I need the positive here, and I'm going to continue on here. I'm going to erase my little picture if you want it. Pause, and here we go. So the positive root, let me just write it here. I want the positive root of 1 minus the cosine of y. We're talking about y, so make sure we get the triangle with y in it. The cosine is negative 2 root 5 over 5. So I have negative 2 root 5 over 5. And then that's all over 2. And this whole mess is under that square root. But in order to combine the numerator, this 1 and the negative 2 root 5 over 5, this 1 I can just call 5 over 5. And I'm also going to call that 2 a 2 over 1. This whole monstrosity is under that square root. But I can combine the numerator here. All right. This becomes 5 minus 2 root 5. That's all over 5. And now that's a single fraction over 2 over 1. All under square root. So I can take my 2 over 1 and multiply it. So this gives me 5 minus 2 root 5. All over 5 multiplied by 1 over 2. Okay. If you need that, pause the video because I need the room. So I can multiply. If I multiply 1, it doesn't change my numerator. I can multiply the 2 into the 5. And so this becomes the square root of 5 minus 2 root 5 all over 10. Okay. And this would be acceptable if you were doing a test where you could write in the answers and say, here we go. Unfortunately, it looks like those days are behind us for the rest of the semester. On the review sheet, I didn't write this review, by the way, but it seems pretty good. I've gone through it. The guy that did write it rationalized by simply multiplying top and bottom by 10 under the square root. Okay. 10 times 10 under the square root, that's 100. I can actually pull that out of the square root. So it's just a 10 without the square root. The square root's now completely in the numerator. Then distributing that 10 through here, 5 times 10 gives me 50. 10 times the -2 gives me -20 root 5, and that's the answer I think they have in the review answer sheet. So that should get you, I think, through 5. There was just a couple others, but they're mostly kind of the same type of questions as the ones that I've just covered. Let's take a look at, I guess we're going backwards here, sorry, out of order, but let's go to 1 and look at number 1. Number 1, I'll do A and B, and then C is just basically some more of the same. Let's take a look at A. A says simplify. In fact, they all say simplify. But A is cotangent theta over cosecant theta minus sine of theta. Okay. All right. Well, maybe that's better. I don't know. But I would start here by writing cotangent as cosine over sine. And then writing cosecant as 1 over sine. And then the sine, I'm just going to write a sine. Since it's in the denominator with a fraction, I'm just going to write it as a fraction. In the numerator, I've just got a simple fraction. I can leave that alone for now. In the denominator, I'm going to combine these by making these multiply the top and bottom by sine of theta. This turns into cosine of theta over sine of theta all over 1 over sine theta minus sine squared of theta over sine of theta. Okay. The denominator is both over sine of theta, so I can rewrite this as still cosine of theta over sine of theta. All over 1 minus sine squared of theta over sine of theta. Again, if you need this, pause the video because I need the room. So what I'm going to do is take this 1 minus sine squared of theta and say that's cosine squared of theta. And so I'll rewrite this then as the cosine of theta over sine of theta over cosine squared of theta over sine of theta. I can now take my denominator fraction, flip it and multiply it. So this becomes, where'd my eraser go? Cosine of theta over sine of theta multiplied by sine of theta over cosine squared of theta. And I can simplify a sine in the numerator, cancels a sine in the denominator. A cosine in the numerator cancels one of the cosines in the denominator. And so all I'm left with is a 1 in my numerator, a cosine in my denominator. 1 over cosine is secant. I believe is the answer in the review. Yeah, it is. Okay. Let's take a look at B. I did B as well. There's an inverse in there. Don't let that trip you up, because we should know how to deal with that as well. B is sine of x over 1 plus cosine of x. Minus sine of x over cosine of x minus 1. And then we've got that -1 power here. I've got fractions. I'm going to have to combine those by multiplying by the common denominator, which means this left one, I'm going to have to multiply both the top and bottom by cosine of x minus 1. And on the right, I'm going to have to multiply by 1 plus cosine of x. In the top, I've got the sine. I'm going to distribute it through the cosine of x minus 1. That gives me sine of x times the cosine of x minus, and the sine gets distributed through, so I have minus sine of x. And that's all over this common denominator of 1 plus cosine times cosine minus 1. So I'm going to actually multiply that out. 1 times cosine is cosine. 1 times -1 is minus 1. Cosine times cosine is cosine squared. And then cosine times -1 is minus cosine. And you can see in the denominator, we've got some things canceling out here. The cosine and the negative cosine just kill each other. And I'm left with a -1 second fraction here. But this is now sine of x, cosine of x, minus sine of x, all over sine squared of x. Okay. On the other one here, I've got a minus. When I take the sine and I distribute it through, I have sine of x. Sine times cosine is sine x cosine x. Right? And I can take this minus and actually distribute it through and then change this to a plus. So in the fraction, I get a minus sine of x and then a minus sine x cosine x. And I have the same denominator, so it ends up just being that sine squared of x. I'm going to write this as all over the same denominator, just minus sine x in the numerator, and then minus sine x cosine x. Okay. Those cancel each other out. And I'm left with negative sine of x. I kind of erased or overwritten that. Negative sine of x, negative sine of x. That's just -2 sine of x. So if you need this, pause your video. This, we said, turns into -2 sine of x over sine squared of x. Right? And the one thing I haven't been writing is that this is all still to the -1. Right? But I can simplify inside this parentheses. A sine of x kills one of the sines of x's in the denominator, but it leaves one. And so this is just, sorry, back up here when I had a cosine squared of x minus 1. This is actually a negative sine squared of x. So that's a negative. So the negative and the negative kill each other. The sine kills one of the sines. And this is just 2 over the sine of x. all to the -1. That -1 is just going to flip your fraction. So this is sine of x over 2, which is what the solution has as well. Okay. Let's look at number 4, was also asked. So let's look at number 4. Number 4 says to evaluate the given expression, and we are given this expression. Cosine of 12 pi over 15 times the cosine of 3 pi over 15 minus the sine of 12 pi over 15 times the sine of 3 pi over 15. Okay. That's what we've got. And then it's important to recognize the identity that's being used here. X in our case is 12 pi over 15. Y is 3 pi over 15. Minus the sine of that same first angle, so that's an x, times the sine of that second angle, so that's a y. But this is equal to the cosine of x plus y. Right? So you add those two angles together inside of a single cosine, and so that's what we're going to do. I will have cosine of x, which is 12 pi over 15, plus 3 pi over 15. Right? I'm going to add these two together inside the cosine. 12 plus 3, they're the same denominator, so I can add these, but this is the same thing then as cosine of 15 pi over 15. But that is the same thing as cosine of pi. Cosine of pi is -1. Number 5, which I did already. So let's take a look at number 6. Number 6 says, start with A. And I'm going to do one of the A's. They're both fairly similar. So I did the cosine version of A. It says rewrite cosine of 2 tan inverse of x over 4. We want to rewrite this as an algebraic expression in x and y. So first and foremost, I'm just going to call this tangent inverse of x over 4 some angle. Why not theta? Right? Turns this expression of x over 4. Right? The cosine of 2 theta, we have an identity for that. That is the positive or negative. Oh, sorry, I'm using the wrong one. I started on a half angle. This is, we have 3 for this. We've got cosine squared theta minus sine squared theta. And that one should do it. Right? What I need to figure out, though, is what cosine of theta and what sine of theta are. So I'm going to create a triangle here. Here's my theta. This theta comes from the fact that tan inverse of x over 4 is theta. That gives me a x value over here and a 4 down there. I have those two sides, and the hypotenuse is the square root of x squared plus 4 squared. So I have x squared plus 16 under a square root. That tells me what cosine is and what sine is. Cosine theta is 4 over that x squared plus 16 under a square root. And this thing gets squared because it's cosine squared, minus, and then sine is x over that. And so if I simplify this, this is 16 over x squared plus 16 minus x squared over that same fraction, x squared plus 16. Trailing off to the side there a little bit. But in the end, I can combine these two fractions. This becomes 16 minus x squared over x squared plus 16. And that is 6. This is A. That's the first one from 6. Okay. All right. And I skipped B. B is similar. And so let's take a look at 6C. So 6C says the sine of the tan inverse of x minus the tan inverse of y. So I have two angles here, right? Or I have two values. I'm going to have two angles because tan inverse of x is going to give me one angle. I'll call that theta. And tan inverse of y is going to give me a second angle. I'm going to call that phi. So I can rewrite this then as the sine of theta plus phi. I should recognize this. It's the sum of sines, or it's the sine of times the cosine of phi minus the cosine of theta times the sine of phi. So if I take a look at the theta, theta gives me this triangle with tan inverse of x tells me that I have a x for my y value and a 1 for my x value. And that also tells me then that my hypotenuse is the square root of 1 plus x squared. Phi here I've got a phi, right? The tan inverse of y is phi. That tells me that I have a y here, a 1 here, and then my hypotenuse is 1 plus y squared under square root. So I should be able to pull all of these values from the two triangles. Sine of phi is x over the square root of 1 plus x squared. Cosine of phi is 1 over the square root of 1 plus y squared. Minus the cosine of theta. The cosine is 1 over 1 plus x squared. Times the sine of phi. The sine of phi is y over the square root of 1 plus y squared. Okay. So then these denominators are the same, so I can just call this x minus y in one numerator over that same denominator of the square root of 1 plus x squared times the square root of 1 plus y squared. And that is 6c. Okay, let's take a look at 7. Somebody asked me about 7a, so let's take a look at that one. We have secant of x multiplied by 2 sine of x minus the square root of 2 is equal to 0. So it's already factored. I have secant multiplied by this binomial is equal to 0. But if two things multiplied by each other equals 0, then either one of them is 0 or the other one is 0. I'll break it up into two equations. The first one here, the secant of x equals 0, will never happen, right? This would require that 1 over cosine of x is 0. But it won't happen. If you try to clear this, multiply both sides by cosine of x, you get 1 equals 0. So this gives me no solutions. Okay. The other one, I'm going to start here by adding root 2 to both sides. This gives me 2 sine of x equals the square root of 2. Divide each side by 2, and I've got the sine of x is equal to the square root of 2 over 2. In one circle, I should know where that happens. That happens at a 45-degree angle and a 135-degree angle, or a pi fourths and a 3 pi fourths, right? And that's all the question is asking for, is just those two angles. I have pi fourths, 3 pi fourths. That's my answer, because in the question it also says that this x, it uses this funky looking e, that means it's an element of, and then it gives us the numbers between 0 to 2 pi. Right? We haven't used this notation very much in our course, but this does mean I only want the x values between 0 and 2 pi, including 0, not including 2 pi. So that's it. It's just one circle. That's my answer. It's pi fourths, 3 pi fourths. If this were not included, then I would go pi fourths plus 2 pi k and 3 pi fourths plus 2 pi k. But it is included, so I don't have to worry about that for this question. Okay, and let's take a look at 12a. 12a says to find the square root, I think. Yep, find the square roots of 4 root 3 plus 4i. So what we're looking for here is 4 root 3 plus 4i to the 1/2 power. And whenever you see a complex number to a fractional power, that means we're probably going to end up with multiple solutions, and that's the case here. The first thing I want to do is get rid of this a plus bi format in favor of trigonometric form or parabolic, or sorry, not parabolic, polar form, excuse me. I do that by finding r to start. R is the square root of 4 root 3 squared. The root 3 gets squared, so that's 3. So 16 times 3 is 48. 4 squared is 16. So that is the square root of 64, and that's 16. That is 8. And a long day. That is 8. Right? Then I want to find theta. So I have theta is equal to the tan inverse of the y value over the x value. So that's 4 over 4 root 3. Right? The 4's can cancel out, so that is to say that theta is the tan inverse of 1 over root 3. Right? But that's the same thing as root 3 over 3. Right? Or is it? I have pi thirds written on my sheet here, but I don't think that's right. It's pi 6. Okay. Yeah. Okay. So I'm going to erase this here, rewrite this top portion as 8 times the cosine of pi over 6 plus I sine of pi over 6. Clean up my workspace here. We're looking for the square root of that. Again, when we find square roots of complex numbers, we're going to end up with of them. Right? Starting with z naught, I'm going to take the r to the 1/2 power. So that is to say I have 8 to the 1/2 power. And then I have that cosine to the pi 6, but divided by 2. So that's pi over 6 times, I'll just times it by 1/2. So I have pi 12ths here, right? Plus I sine of pi over 6 times 1/2, right? So the square root of 8 is 2 root 2, right? You can just call that root 8. You can pull out a 4 as a 2. You leave a 2. And then I have cosine of pi over 12 plus I sine of pi over 12. Right? And that's my first. That's well, 0, first, whatever you want to start counting. That's the first answer you come across. For the second solution, we're going to call that Z1. That's all there is, right? If your denominator and your power is 2, you're going to get 2 solutions. Z1 is my second solution. It's going to have that same radius, 2 root 2. Right? I don't know if that's enough room. Let me just erase this. And go right here. Well, I'm still going to have the same radius. I'm going to have the same radius through the whole thing. This is then cosine of this initial angle, pi over 12. But I add to that 2 pi divided by 2 plus I sine of the same thing, pi over 12 plus 2 pi over 2. Right? So this is 2 root 2 times the cosine of, in order to combine these, I'm going to want to multiply this guy maybe by 6 over 6. That gives me 12 pi over 12. So 13 pi over 12. And then, of course, my sine is the same angle, 13 pi over 12. And those are my 2 solutions. So let's look at 12b. 12b says to solve z to the fourth plus 1 equals 0. So if I simplify this here, minus 1 on both sides, this gives me z to the fourth equals negative 1. Or I'm really looking for solutions to z equals negative 1 to the 1/4, right? So if I ignore the idea that this whole thing is an equation anyway, it's really just asking me to take negative 1 and find the fourth roots of it. So that's the question that I'm going to answer, and that answers this initial question. So that is to say I have negative 1 to the 1/4, but negative 1 is negative 1 plus 0i, right? It's still a complex number, it's just completely real. That just means there's no imaginary portion. I can still write this in polar form. It has a radius of 1, obviously, because 1 squared is 1 plus 0 is still 1, and then the square root of that is 1. It has an angle of, if I try to figure it out, I go tan inverse of 0 over negative 1, but that's the same as tan inverse of 0, and tan inverse of 0, if you're plugging that into a calculator, which you shouldn't be because you don't get one on your test, it'll spit you out 0. That's not your angle, right? It's not, because you have a negative 1 in your real and a 0 in your imaginary. If we plot that on a complex plane here, negative 1 is here, where I've got my real, I've got my imaginary. Obviously, I have to add 180 in order to make this correct, right? So my angle is pi. Get rid of this because I'll need the room in a minute. All right, so I'm taking this number to the 1/4. And therefore, I'm going to end up with a z0, a z1, a z2, and then a z3 finally. Each of these are going to have r, which is 1, raised to the 1/4, but the fourth root of 1 is 1. Right. And then they have a cosine of, my initial is pi divided by 4. So I get pi fourths plus I sine of pi fourths. That's my first guy. The radius on these guys is all going to be 1. It's 1 across the board here. My second solution here, z1, is going to have cosine of that same angle, pi fourths, plus, and I see this 2 pi, this is plus 1 pi over 4 is 3 pi over 4. And so this is the same thing as 1 times the cosine of 3 pi over 4 plus I sine of 3 pi over 4. Ran out of room there. Hopefully you can still see it. The joys of working with the teeniest whiteboard. But this 2 pi over 4, that's just having pi halves every time, or 2 pi fourths every time. And the next one here, if I do it by the formula, is just the cosine of that same initial pi fourths plus 2 pi, but times 2 over 4. So that's just 4 pi fourths plus 1 pi fourths. This is going to give me 1 times the cosine of 5 pi fourths plus I sine of 5 pi fourths. And the next one's going to be similarly 1 times the cosine of 7 pi fourths plus I sine of 7 pi fourths. And there's our 4 solutions. Right. You might have to take these solutions and then put them into A plus BI form, right? But you should be able to do that. Cosine of pi fourths is root 2 over 2. Sine of pi fourths is root 2 over 2. So I have root 2 over 2 plus I root 2 over 2. And you can do that similarly for all of them. I won't do that here. You should be able to do that. All right, let's take a look. I think at one. "13 says A says convert from polar into rectangle coordinates. So I have R equals 4 over 1 minus 2 cosine theta. The key here is to use the identities that we have. We have R squared is equal to X squared plus Y squared. I have X is equal to R cosine theta, and Y equals R sine theta, and then theta is equal to tan inverse of Y over X. So I have an R, but I can't do a whole lot with anything else here. So I'm not going to turn this R into anything just yet. What I'm going to do is multiply both sides by this denominator. So I'm going to multiply both sides by 1 minus 2 cosine theta to both sides. So this gives me R times 1 minus 2 cosine theta is equal to, and I just have a 4 left because they cancel out the denominator there. And I'll take and distribute this R. So I get R minus 2R cosine theta equals 4. And this R cosine theta, I can write that as X now. So I have R minus 2X equals 4. And I'm halfway. All I need to do is figure out what to do with this R. To figure that out, I'm going to erase this. Give me some more room here. Well, that's what we got to. I'm going to add 2x to both sides to isolate my R. So I have R equals 2x plus 4. And I'm going to square both sides. That gives me R squared, which I can then turn into x squared plus y squared. On the right-hand side, if it were me just writing my answer in a test, I would just leave it as 2x plus 4 squared. Turn my R squared into x squared plus y squared is equal to 2x plus 4 squared. This answer is totally acceptable. It's right. In the solutions, however, this right-hand side is then expanded. 2x plus 4 would then be 4x squared plus 16x plus 16 if you were to FOIL that together. And then if you subtract everything off to the left-hand side, you get what's in the answer solution for the review answer key. And that is 0 equals 3x squared plus 16x plus 16, and then minus this y squared. Again, the way that these tests are going to be built, there's going to be a lot of multiple choice. On top of that, there's also going to be a lot of options in the multiple choice. It's not just going to be like a Scantron A, B, C, D. You might have 10 or 15 possible things to select from. So know how to turn your answer into different forms. That'll be important. Okay. That is 13A. Let's take a look at 13B. (13B) is similar, but actually much more easy, much easier. In 13b, all I'm going to do is multiply both sides by r. Multiply the left by r, multiply by the right by r. On the left, that gives me r squared. On the right, I'm going to write the r between my 9 and my sine because I want to see this 9 sine of theta, or sorry, r sine of theta. Because r squared is x squared plus y squared. R sine theta is y, and I'm done. Right? You may not have to manipulate it, subtract 9y from each side, get it to the left. I don't care, but again, if you have to find an answer, be able to manipulate those. So hopefully this was helpful. Hopefully it recorded the whole thing. Looks like it's about 1 hour and 3 minutes now. So if I post it and it's any less than 1 hour and 3 minutes, I will probably go crazy. And well, let's just leave it at that. Post any questions you have in reviews. Other students can come on and answer those questions, or you can answer questions people post. I'll also be watching those. But again, the idea here is that we will be hopefully being able to do this live and have anybody come on and ask questions as we go through it. So that's the goal. And now that I have decent internet, that might actually happen. So take care. Again, post questions in the discussions, and good luck on your test on whatever day. Whatever I did at the beginning of the class. Wednesday.